Hello, this is Dr. D, and we are continuing with cardiovascular system. So today we are going to talk about action potential first. All right, this should have been covered by y'all in 201. So this is going to be a quick review. All right, so now let's see. So what did we notice? We said that the heart muscle can initiate, or it can activate or generate an action potential. What's an action potential, by the way? Action potential is a very weak current. All right. Now, need to understand those basic concepts. When does a current flow? A current will flow always when there is a difference of charges. All right. You can think of it as like a water tank. So let's see out here. Look at this water tank filled with water. There's no water in here. When I connect A and B, will water flow from A to B? Answer is yes. Why? Because there's more in here, less in here. And that's basically what an action potential is. It is a small electric current generated because of change in or difference in charge. Now, what am I talking about charge? So we are going to talk about ions first of all. Okay, and what are ions? This is an ion. Ion is a charged particle. So sodium ion, potassium ion. This sodium is not an ion. It's not a charged particle. Do you see the charge? Plus, plus. So what about chloride? Minus. Do you see this? This is an ion. All right. Here I'm going to take a cardiac cell. So in a cardiac cell, what I notice is always for any cell, sodium ions are outside. Okay, I'm going to draw some sodium ions. And potassium ions are always on the inside. Okay. So here, let's draw 5 of them. So at rest, in a cardiac cell, some potassium leaks out. Okay, so potassium is leaking out. So what do you notice? That there are now how many charges? 1, 2, 3, 4, 5, 6. And how many charges inside? 1, 2, 3, 4. So what happens is now the outside of the cell is positive and inside of the cell is negative. There are more positive outside and less positive inside, making it slightly charged outside and slightly charged inside. I said slightly. Okay. So this is at rest when the some potassium leaks out. So this gives a resting potential and the cell is said to be what? Polarized. Now when the message comes, when a stimulus comes, then what happens is these sodium ions rush inside via sodium channels. Sodium channels are like, these are membrane proteins. They will allow only sodium to pass through. So sodium is going to rush inside. Okay, so here sodium is going to rush inside. So 2 sodium have gone in. Let's count sodium in. Okay, I'm going to put the sodium in right here. I'm going to put sodium, this is sodium and sodium, round and round. Now what happens? Inside is positive, outside is positive. And the cell is said to be what? Depolarized. Okay. In a cardiac, now this was what was happening in a regular skeletal muscle. But we have a third player. Now what happens is further depolarization takes place. How it happens? Another molecule, I'm going to put a star mark in here, and these I'm going to donate as calcium ions. Look at the ions. There are 2 charged particles, right? So this calcium is going to now further enter. So now inside it has more positive. It had potassium, some leftover potassium. 2 sodium entered and 2 calcium entered. Oh my God, making the inside way more positive than the outside. So the cell is further depolarized. All right. This is further, cell is further what? Depolarized. Now the slow gated channels potassium open, and now these potassium will leak out. They will move out. Only problem is that more of potassium leaks out than the sodium and calcium combined entered. So here what happens is we are back to the original. There is more, outside becomes positive, inside becomes negative. At first, what was it? Outside was positive, inside was what? Negative. Yes, that was 1. Second step was what? Outside was positive, inside was what? Positive. Third step, we are back. Outside is positive, inside is negative. Here the cell is said to be polarized. Here the cell is said to be depolarized. D means no poles. Third is what? Repolarized. Outside is positive, inside is negative. Alright. So here it is repolarized. So now what? So because of this change from positive outside, negative inside, positive, positive. So change in potential or voltage. Because of this change in voltage, which is measured by the difference in charges, okay? So because of the difference in voltage, then what happens is a small current is set up, and that small current is called what? Action potential. And if I were to graph this, notice that here you are seeing this is when the potassium channels are closed and the slow sodium channels are allowed entry. Now the calcium channels you see, so you see it jump, right? So here you're seeing jumping. Now what happens is calcium channels close, but potassium channels open, and potassium leaves the cell. So you will see this with the sodium. This is the effect of calcium. This is the effect of potassium. But notice the importance of calcium. That is something that you cannot forget. If calcium was missing, this surge in the depolarizing will not occur. That's what I want to stress at. Alright, so how does the nervous system help regulate? So once again, there is a cardioacceleratory center and there's a cardioinhibitory center. So cardioacceleratory center, it does this by a sympathetic, by VA sympathetic neurons will cause the heart rate to what? Increase. The cardioinhibitory center, VA, or with the help of parasympathetic nerves, will help to return to normal. Are you understanding? But this cardiac control, where is it found? In the medulla oblongata. So whatever I'm underlining, whatever I'm stressing on, make sure you're reviewing this. All right. So where is the center? Medulla oblongata. From the center, the big guy is going to control the heart via what? Sympathetic neurons and parasympathetic neurons. One will activate, increase the heart rate. One will decrease the heart rate. Of course, there are other emotional factors like temperature or emotional response. Or what happens is the amount of calcium. Now, if there's more calcium, what's going to happen? What do you think is going to happen? If there's more calcium, you are going to increase the rate as well as force of contraction. We will talk about this later on. Now what happens is if you have excess amount of potassium in the outside, if there's excess amount of potassium, that is going to interfere again, and the heart will not go back into the next action potential. This is one action potential. This is another action potential. Are we understanding? So if a person is given an injection with very high amount of potassium, the next action potential will not occur. Okay. All right. So if you understand this, you should understand what's an EKG. What's an EKG? We just said that in the heart, one heart muscle, there is this action potential. But remember, heart is made up of many heart cells, right? And each heart cell will have its own action potential. A sum of the action potential can be represented in the form of EKG, and you will see it as waves. So is EKG and action potential the same? No. Action potential is 1. Sum of action potential is EKG. Keep this in mind, okay? All right, so here we see first is the P wave. This small first wave is called the P wave. Do you see this? This is the P wave. Okay, here's another P wave. The P wave is caused by what happens is this will when it starts depolarization in the SA node, it will cause the P wave. What's the P wave? After the wave of this, the depolarizing. Okay, first of all, of the atrium, and after this wave only the atria will contract. So P wave represents what? Depolarizing of the what? Atria, and after this the atrium will contract. Now is the QRS, this QRS wave. This QRS wave is the depolarizing of the ventricles. Notice how big it is. And only after this wave will the ventricles contract. Please keep this in mind. A good question to ask, why is the QRS wave bigger than the P wave? What was the P wave? P wave was the depolarizing of the what? Atrium. This is the depolarizing of the what? Ventricles. Which one is bigger? The ventricles or the atrium? The ventricles are bigger. More muscles. Therefore, bigger sum. Yes? More muscle cells means a bigger sum. Less muscle cells in the atrium means a smaller sum. And what is a EKG? EKG is nothing but the sum of the action potential. All right. So here, then is the T wave. The T wave is the repolarizing of the what? Ventricles. And only after this will the ventricles relax. So good question to ask is, why did we not see any wave of a repolarizing for the atrium? Well, the answer is that the atriums, it is so small that it does not register. All right. So you have the P, Q, R, S, T wave. And here are the heart rhythms. Normal. This is damaged. This is ventricular fibrillation. Very, very dangerous. It means, notice what does it mean? There is no QRS wave. And until QRS wave does not occur, what's not going to happen? Ventricles will not contract. If the ventricles do not contract, will the blood be pushed out of the heart into the lungs or into the aorta? Answer is what? No. Right? So here, this is because of obstructed coronary artery, toxic drug exposure, traumatic injury, or electric shock. Here is tachycardia, very rapid heartbeat. Brady means slow, slow heartbeat. And then there's something called atrial fluttering. Do you see that here there is a flutter in here, which is a rapid rate of atrial depolarization. All right. So I think we'll come to a stop here. And if there are questions or concerns, please reach out to me. All right. We'll continue with the next in the next presentation. Thank you for listening to me. Have a good day.